Okay, I think we'll get started. Let me close my music player here. I don't accidentally play music. We have a very small turnout tonight. I think the week off might have cost me some students, but hopefully the benefit will be we have a smaller group. And so if you have any questions at all tonight, it's a small enough group, just pop onto the audio and speak up. Tonight we are going to do two subjects, reading and writing files. And then I really want to, for the second half or so, I really want to get into working on a project together. So I've come up with something that I hope will be of interest to you all, and we'll kind of work through the project, as I say, in the notebook together. And then we'll just sort of build on it in the next few weeks and add more functionality to it. So this is really sort of trying to turn the corner now and apply some of the things we've learned to solving problems together. You all have the notebook, mco.fyi/pi6. Go ahead and make your own copy if you'd like, with files, save a copy and drive from up here. Let me go full screen with this. And if you'd like it bigger, just say something in the chat and I'll increase the magnification. I think it's, let's see. Yeah, 200%. So it seems good here, but let me know if you'd like more. Okay, so reading and writing files. Why do we care about that? Well, for one thing, the programs we've written so far, outside of the notebook, they sort of forget themselves after the program is finished. So anything you entered to an input prompt or any computing you did, it just sort of disappears when the computer's turned off or when the program is finished. And so if you imagine, a service provider or a bank or, anything that, like Amazon or a retailer, anything that has a notion of subscribers and wants to keep track of who you are and what you've done, needs to make that information permanent. And that's where storage devices come into play. So there are a couple types of storage we can refer to. One is main memory, and the other is disk storage. And I apologize for people who know this already. This is somewhat basic stuff for computer folks, but I know some of you are maybe relatively new to programming and to computers. So anyway, the difference is that main memory is really fast and generally smaller than disk or secondary storage. And it's also transient. So whatever you store in main memory, when you turn the computer off, it's gone. Why do we even use main memory? Because that's where we get the speed from. And it's a little bit like, actually, I'll make this analogy in a second. The alternative to main memory is disk storage or secondary storage, which is slower and much higher capacity, but it's also permanent. Okay, and so the difference is that main memory is sort of like your brain's memory, right? So you remember to do something. If you're like me, you probably forget a lot, but you can get access to your memories really fast. So if someone asks you something that you're interested in and you know the answer, you just like that, you have it. A disk is like writing something down. And so for stuff that you may not be able to remember, you write it down and you can always go back and get it, but it's slower than just pulling it out of your brain cells. So that's kind of the computer version. A main memory and disk storage are kind of the computer version of your brain's memory and the things you write down. Everything we've done so far has been based on main memory. So whenever you do an assignment statement, when you define a function, when you do a computation where you multiply numbers together, whatnot, that's all living in main memory. And so that's sort of the easiest way to program, and you kind of get it for free. When you want to actually save something permanently, you have to start managing the disk storage. And there's a couple of things you can do to do that, and we'll walk through what those are. But you're basically going to want to put the information in something called a file. I'm sure you know that word. You've used files all the time. What is it really, though? Well, it's just a chunk of information that's organized on your disk in a discrete unit that the operating system knows how to fetch for you and how to change and write based on your instructions. The files are organized in a hierarchical fashion. So there's a sequence of folders or directories. I'm sure you've seen this in either the Windows Explorer or the Mac Explorer, where you'll kind of like drill down into these folders. And each folder has a corresponding name, and then at the bottom of the list of folder names is a file name. So any kind of specification of a file will have two components, typically a path, and the path is kind of like where the file lives, the sequence of folders where the file lives, and then the thing at the end, the file name, which is the actual name of the file. And by the way, Windows and Linux or Mac users will notice that the separator character between the folders and the file names and so on is backslash on Windows and slash on Unix-derived systems like Mac and Linux, which has caused untold amounts of annoyance for people in the last 50 years, but we've kind of gotten used to it by now. One last thing about these path names and file names. If you think about how you would address a letter to someone, you kind of give the name of the person and the address of where that person lives. The where they live, so in this example, the Buckingham Palace, that's the path name. That's kind of like the path name. And then it gets to that location, and then you look on the envelope to see, okay, who is this for in this house or in this palace? And that's the file name. That tells you the what or the which thing you want in that location. Okay, so that's a real quick background on what a file is and why we need them. How do you manipulate them in Python? I'm going to just walk through a few different functions that we use to operate on files. The first thing you have to do is open a file. So this is your way of telling the operating system, there's a file here and I want it. I want to open it. I want to do something with it. Or it might be that there's a file here that I want to operate on that doesn't exist yet. I want you to create it for me and I want to put something in it. So open is the first step to operating on any file. The syntax is like this. You call the open function. You give it a name or a path and a name. Depends on what you want to do, where that file is relative to you. But basically, you give it a specification. The first argument is a specification of which file you want to operate on. And then you specify a mode. And I'll get more into what those modes are all about. But the simplest thing to know is they're either telling the operating system whether you want to read or write a file. Excuse me. So, yeah, let's jump to, the open function returns an object called a file object. And so that's why the syntax you see here is file equals open. Now this file is just a variable name. I could call it anything I want. And it's just a standard assignment statement. I call open, I give it my specification, it returns to me a value that I store in this file variable. And then I can do operations on it. So the one thing I didn't explain in this open call is that second argument, and that's we call the access mode. And that just tells the system what you intend to do with the file. So R means I'm going to read, W means I'm going to write, and A means I'm going to append. So append means the file's already there, and I want to write at the end of it. I want to basically add on to what's already there. There's also these sort of combination modes, R plus, W plus, A plus. Don't worry about that too much. They're a little less often used and a little complicated in certain ways. But this table gives you a rough idea of what each mode is doing. It also tells you what will happen if the file already exists or if the file doesn't exist. And the thing to know about is when you do a read, the standard case would be the file exists, right? Like if there must be something there to read. If there's nothing there, then there's probably a problem. So When you open a file with the access mode R, if the file exists, it opens, and you get returned this object that you can then work with. If it doesn't exist, you get an error, which kind of makes sense. When you do a write, if it exists, you overwrite it, and you get back the file object. So you could have something very valuable in there. If you open it for write, you've just wiped it out. And if it doesn't exist, it gets created, and you get the file object. So write is always going to succeed whether it exists or not. But if it does exist, it's going to get wiped out before it opens or before it returns to you. And then append is, as I said earlier, if the file exists, it's going to open it but sort of leave what's there and let you write after the end of what's already there. If it doesn't exist, just like the write case, it'll create the new file and open it for you. Any questions on open or access modes? Suvo said, is there a mode X available for execute a file? That's a different, there is something in Linux called execute mode, but that's what we call a file permission. So that's like a different mode than the mode we're talking about here. So you typically will set that through a command line or an operating system utility, not from within Python. When you use these specifications, you're just telling Python how you want to work with the file. It doesn't change anything about the file, whereas the execute permission that you're referring to actually changes the state of the file and marks it as executable or not. If there are any other questions, just jump on, unmute yourself and just yell. So if you have to open a file before you can operate on it, the obvious analog to that is you have to close it when you're done operating on it. Why do you even have to bother? Well, there's a couple of reasons. One is you want the operating system to do the proper house cleaning. For example, when you write to a file, it doesn't always go right to the disk. Sometimes the operating system will buffer it up, meaning it will keep a copy of what it's supposed to write. And it does this for performance reasons because it takes much longer to write to the disk than it does to write to memory. So if it actually when you do a write, if it pushed the data all the way out to the disk and then returned, you'd be waiting a long time, or a long time means milliseconds, but compared to a memory write, it's a long time. And so in order to speed things up, when you do a write, the operating system says, okay, it's written, but it's really lying. It hasn't written it yet. It's put it in a queue to be written when it gets around to it. And when you say close, it tells the operating system, I'm done with this file. Make sure everything I wrote gets where it was supposed to go. In reality, you rarely have to worry about this because things just work. But it is entirely possible you could do a bunch of writes and the system could crash and it wouldn't get written to disk. So it's a good idea to close your file when you're done working with it. Close is a method on the file object. It's a little bit asymmetric because open is a function, whereas close is a method on that file object that you get passed back to you from open. Why is that? There's sort of like a chicken and egg thing there, right? If you can't call file.open to open it because the open call is returning the file, so you don't have the file yet to call a method on it. So open is a function for that reason. Close can be a method associated with the file because at that point you have the file open and you can operate on it. Sort of a technicality, doesn't have a lot of, not a big thing to know about, but the main thing is you open files when you're going to start working on them and you close them when you're done. Here's an example of how you write to a file. You take the file object .write, so it's a method of the file object, and you give it a string, and you have to put this new line at the end if you want separate lines in a given file. You have to have opened that file for write access, and it simply writes the pass string into the file. Let's actually take a look at this. So here's some Python code. I'm saying f equals open test.txt, And I'm saying I want to open this file for write. And by the way, this file I think doesn't exist, so it's going to just create it for me. I'm saying I want to write this file. If it does exist, it'll wipe it out before returning from open. But either way, I'm going to get back this, in this f variable, I'm going to get back a file object or a reference to a file object. Then I'm going to say f.write. This is my test file. And then for I in range 10, so I'm just going to jump through a loop 10 times. I'm not even using the, oh yeah, I am using the I here. I'm going to write line number, space, and then that value that I'm iterating on. So the first one's going to be line number 1, then line number 2, and so on. And when I finish the loop, I'm going to hit F close. So let's run that. And nothing happens because I didn't do anything to verify it, but it created that file. And we'll see the contents in a minute, because the next thing I want to show you is reading from a file. So as you might guess, you say file.read instead of file.write. Now, whereas f.write or file.write didn't return anything because it just does what you asked it to do, file.read does return something because you're asking the system what is in the file. So it has to have a way of telling you, and that comes as a return value, which you want to store in a string using standard assignment statement syntax. The file has to be opened for read access. It reads the entire file into memory and gives you that result, as I said, in a string. You can pass an argument. If you want to tell it only read 5 characters or n characters, you can pass a number there. So now let's read the file we just wrote. F equals open test.txt, and now we're saying R for read access. We're saying S equals, S is kind of a, these variable names aren't great, but it's just going to be a string that comes back from f.read. So whatever I put in that file, it's going to come back in this string. I'm going to close it and then print the string to see what I got. So let's run that right now. And as you can see, I have, this is my test file, line number 0, line number 1, line number 2, and so on, all the way through line number 9, I think. But that's kind of not what I really wanted. Does anybody have any idea what I missed or did wrong here? I'll give you a hint. It's not what in the reading, it's actually up here when I did the writing. So the clue is you have to include new line characters where you want them if you want to delimit things by lines. So what I did here was I said line number I, and that's it. So it just kept adding those strings together into the file. And so what I can do to fix this is say plus 1 character string containing a new line. And I will do the same thing up here to say this is my test file. In this case, I don't really need the plus because I can just throw it in the string like that. In the other case, I needed the plus because the last thing here was a separate string expression. This is converting the I, the loop counter, into a string. So let's run that again. Now, hopefully we got 1 per line, and we'll test it by opening and reading the file. And we see what we expected now. We got 1 line, 1 line that we output is now 1 line that we input when we read it back in. Any questions on that? Okay, now I want to show you a really nice pattern for iterating a file a line at a time. And what I really like about Python is that you just sort of see these patterns coming up over and over again. And once you get used to using it with one data type, it just makes sense for some other data type. So here's an example of how we can use a for loop to iterate through the lines in a file. We say for line in file. So what is line there? Line is just a variable, it can be anything. I could say for x in line, for I in line. Sorry, for x in file or for I in file. What is file? That's a file object, whatever came back from the open function. And what this does is it reads one line at a time into my program. And each time it reads a new line, it sets the variable after the for statement, or after the for, to that line. So this line variable gets each line one at a time. It's sort of like saying to Python, go through this file one line at a time, and each time, with each line, set whatever variable name I've set here to the new line. And then it iterates through the loop like it would with any loop. The string will include the new line if there is a new line at the end. And this is just a super convenient way to process text files one line at a time. The other thing is this is super efficient because the files we're playing with right now are really tiny toy files, but you could imagine a file could be terabytes, could be huge. And when we do this sort of naively, we say f.read here. That says read the whole file in and put it in memory and give it to this, assign this variable s to that huge chunk of memory. And that's not just efficient, that can like blow up your program. If you have too big of a file, you literally will often not have enough memory to store that much information. So going this way with the iteration through the lines in a file avoids that problem because you never have to worry about pulling more memory in than one line at a time. So it's much more efficient. So let's actually go through the process of using this pattern. And this is kind of going to give us the same results as this program. So let's actually copy this one and compare it to the one I want to show you. That cloned the whole cell. I did not want to do that. Try this again. Okay. Let me get rid of this extra cell. Okay, so this code is saying f equals open, just like we've been doing all along with access mode R. And then we're going to use this pattern for line in f. So that says iterate through this loop with every line in the file getting assigned one after another to the variable line, and then print line, and then f close. So we'll run that, and it should give us the same result. Anybody have any idea why we have this slightly unexpected thing of an extra line between everything we're printing? Just jump on the mic if you have any thoughts. And while you're thinking about that, I'm just going to compare these two pieces of code. The f open call is exactly the same. So this line is the same as its partner. The close is the same. What's different is this for line in f, whereas in this case we read the whole file in and we printed the whole file. With this pattern, we're just kind of going through a loop one line at a time. The reason we're getting that extra line is because, or extra blank line between every line of output, is because the lines in the file have those new lines at the end, and the print adds a little new line at the end. So we're getting two new line characters, one here and one here. And that's why we have one extra new line at the end of every line that we don't really want. So there's two ways we can fix this.
So you're saying that there's a built-in new line like the /n in the for loop? Is that what you're saying?
So there is a new line in that file. Like if I actually open up this file, what am I doing? This is in the notebook, getting confused. Let me do this. I'm going to create a code cell up here. If I do ls, this is just a Linux command for seeing if a file is there. So if I run this, it should show me that file is there. There it is. Now I'm going to say cat test.txt. That's going to show me the contents. So that's what the file looks like And the file has those new lines right in it. And so when I read the file, I'm getting the new lines along with everything else. And when I do this for line in F, each line is including the new line. So when I do print line, what's happening is, let's say an arbitrary line in this input, it's going to print line number 2 and then a new line character. But then the print statement is going to do what it always does. It's going to automatically add a new line. So I'm going to get an extra new line. So there's two ways to fix this. One is I can tell print, don't do what you normally do. If you remember, there's this setting end. I can say to end equals empty string. So don't append new lines at the end of everything. And if I do that, it looks as I would expect. The other way I can do it is I can just let print do what it wants to do, and I can fix the line, each line that comes in, I can strip the new line off of it. And it's actually quite easy to do that. I can say s equals line.strip. There's a string function that strips white space characters at the beginning and end of a string. So now if I strip the new lines, then I can allow print to do what it wants to do and it'll work fine. If I do both, I'm going to have a problem. If I do end equals null string and strip, then I'm back to this thing where everything's just one big long string. So hopefully that makes sense. I'm gonna get rid of the strip because it's a little more work, and I'm going to go back to just using end equals null. And why isn't that working? Because...
Oh, because it doesn't know what S is anymore?
Thank you. Saved me some time there. Okay, good. And that kind of raises a good point. This line, it might seem like that's a special name, and I mentioned this already, but that can be anything. So let's say, call it text. As long as I do what you just told me to do, which is make sure that the variable as I use it is the same as the variable I defined in the for loop, that name can be any variable name I want, and Python will be perfectly happy. Same with this F. I can call it my file, and as long as I'm consistent so that I define it with the same name as the one I'm using when I use it, everything works fine. So hopefully this pattern is clear. For variable in file, in file variable name, as long as the file's been opened, and I define this variable and I use the variable in some useful way, everything's going to be fine. What happens if I don't open it? Going to have a problem. But I would have expected more trouble than that. And I think it's because it might still be open. It actually should have been closed. So I'm not sure why I didn't get an error message. I'm just going to try restarting the runtime. Yeah, because my file was already there, but it really should have thrown an error. So now I'm getting my file is not defined. If I define it, and I'm using F here. I never closed it. That's why, because I changed the file up here to my file, but down here it was still F. So I was closing the F repeatedly, which is redundant, and my file was staying open. So let's try this. This works now. And let's comment out the open. And now we get what I was expecting to get earlier. IO operation on closed file. So hopefully that makes sense. The last thing in this section, actually there's two more, but the last sort of new statement or new syntax I want to share with you is called with. And the idea behind with is quite simple. It just automatically ensures that the file gets closed. And it's not unique to files. You can use with other objects as well, but this is the first time we'll see it, and it's probably the most common use case for with. Without with, which is a weird phrase, we have the same pattern you've seen all along. File equals open, then we do something with the file, and then file.close. But if we want to use with, we can say with open as file, and then do some operation. And then we simply don't need to do the close. The with makes sure that the file gets closed automatically. So one way to think about this with, trying to think of how to do this. Yeah, let me make a code cell. Okay, so the with open, this line, is kind of like saying f equals open test.text, comma r, and then whatever is indented gets run. And then there's sort of like an invisible implied f.close. So all this is really doing is it's protecting you from forgetting to close the file. But it's actually even a little bit more than that. What's also happening is, imagine if you do a lot of stuff in this with clause and something fails horribly and your program crashes. Your file will not get closed and you could even lose information. The with clause means if something bad happens in here, close the file, make sure the file gets closed. So it's really giving your code sort of a safety valve in case something goes wrong. If you wrote your code the other way, where you did the explicit open, then some operations, and then some close, and the program crashed before the close, then you would have no such guarantee that the file would be closed. Probably more than you needed to know about that, but it's a convenient pattern, and you'll see it a lot. So here's a summary of some file functions and methods. Most of these we've seen. There are a couple here we haven't, but there are really many, many functions to do I/O, and depending on how you want to process the file you're working on may nudge you in one direction or another as to which set of methods you want to use or which functions you want to use. So we've seen open and close. We've seen read, where you can either give it a number or nothing to read the whole file. Haven't seen this one. It's called read lines. It reads all of the lines in the file. If you're starting from scratch, it's everything. If you've already been reading, it'll read from wherever you left off to the end. And it'll return to you a list of strings where each string is another line from that file. We saw write, and that writes a string. And then write lines is the partner of read lines. You give it a list of strings, it iterates through that list and writes the strings into the open file. You might wonder, where do you pass the open file? And these are all methods on the file object. So you'll say file dot or f dot, whatever your variable name is, dot, and then this method. And then open, as I said earlier, is just a function, because that's sort of how you get started creating or opening a file. And that is it for a quick overview of reading and writing files. So any questions on that before I keep going? Okay. Before we go any further, I wanted to have like just a short interlude here where we talk about what's actually happening when you're working in this environment. In other words, when you run a cell, when you click run, where's it actually running? And so this particular notebook is hosted by Google. And so there is a computer somewhere in a data center, and a data center is just kind of like a warehouse of computers, row after row of computers like this photograph. And in fact, all of these computers, all of these servers are running Google applications. Some of them could be running Gmail. Some of them could be running Google Search. Some of them are running these Colab notebooks. A very, very, very tiny proportion of them are running Colab notebooks because it's nowhere near as big or as compute intensive as, you know, Maps and some of the other high-end services. But anyway, These computers are allocated dynamically when someone needs to do some function, either search or look up an email or whatever. These processes are allocated on the fly. And so you end up having some service that's being performed for you somewhere in the world, typically as close to you as physically possible, on some randomly allocated piece of equipment in a data center like this one. You can find out more about Google data centers by following this link. I don't mean this as a commercial. I just I find this stuff interesting just to see what's going on behind the scenes, because there is a lot of interesting stuff that goes into building as big of a service as Google, and you can find out more about that at that link. But anyway, I tried to put together this little pictorial view to give you a sense of what's happening. So when you're using Colab, you're looking in your web browser, you're running this application. It's called Jupyter, and it is talking to a server in a Google data center. So this picture down here is supposed to be a random server. It's not actually one of the Google servers, but it's like, you can sort of see that it's like an industrial kind of computer that you would put in a rack. And what's happening is when you click that run button, this application takes the Python code in that cell and it sends it to this computer. And that computer runs it just like when you're running locally, when you do the Python command to run a file locally. It runs it on this server, and it says what came out, what was the response. It packages that response up, sends it right back to the requester, and the output gets presented on your screen. So there's kind of like a conversation going on between your web browser and this server in Google's backend, or in Google's data center. Now, it turns out that these servers are statically allocated to your notebook for the most part. And so that's why when you see this RAM and disk here in the upper right, that's giving you some information about the server that's serving your notebook right now. And once you start working with that server, you tend to stick with that server. And the reason is all of the state information is stored there for your notebook. So let me make that explicit. If I say name equals Mark, and then I come and run another cell, completely unrelated cell, print name. Now when I click run, it's going to send this Python code to the server, and the server is going to run it. And if it just sent it to a random server, it wouldn't have this setting for this variable. So because it's using the same connection and the same server over and over again, the server has what we call state. The notebook has a state behind it, and it's reusing that. Now, if I ever restart the runtime, this is effectively saying restart the application on the Google server that's kind of providing the back-end engine for this notebook. If I say restart runtime, it gives me a warning, and now I'll wait. Up here it said initializing for a second. It actually tells you the name of the server it connected to, Python 3 Google Compute Engine backend. So now if I come down here and I say print name, it says Mark is not defined, and that's because the backend where all the state information is just got restarted and it lost that setting of name. So it's just a little bit about how, what's going on when you're running one of these notebooks. When you're running locally, so here's that mu IDE, the same kind of thing is happening, except it's running the program on right on your local computer, on your local laptop. It's a little bit different because this isn't a notebook. It is possible to run a notebook locally and have the same kind of conversation going on between your notebook and your local computer. But with Mu, it's actually just running the code right in that application. But effectively, it's the same thing. You get to say, run this thing, and it doesn't have to do anything with a server on some other computer. It just tells your laptop to do it, and it does it. So that's a little bit about what's going on when you're using these notebooks. The notebooks are a little bit of an artificial environment, right? It's a little bit like learning to ride a bike with training wheels, because a lot of the details and the administration and the lower level of what's happening is taken care of for you. And that's really great for beginners because it just takes away a lot of issues that normally you would have to worry about. But as you get further along in your programming career, you'll want to get more and more to being able to run programs locally outside of the notebook environment, because that's more real world. Like, people do use notebooks for quite a lot of things in the real world, but when you develop programs to be reused by other people, you'll typically send them the programs. You won't kind of give them access to a notebook. Okay, enough of a digression there. Let me clean up a couple cells. And we are at 45 after, but we're kind of jumping into this project I want to work through with you. So rather than do that for 5 minutes and break, let's just do the break a little bit early, and let's come back in about 10 minutes. So 5 to 8, we'll regroup. And I'll be here if you have any questions that you want to ask during the break. Okay, welcome back. Hopefully you're seeing my screen. And what we're going to do is just work through a problem together. And what I'm hoping to do is to just sort of naturally apply a bunch of the things we've been working on all along here, and also give you a sense of how we can approach a compound problem where we need to solve a bunch of sub-problems. Again, let me know if the notebook looks too small for you. And let's get started. So here's a problem statement. We want to create an application that lets people automatically find articles that they're interested in from news sites. And some of the requirements are that we have to have a configurable list of target websites. So the end user has to be able to customize this app so that they can tell us which sites they're interested in. We also need to give the user the ability to tell us which topics they care about. We're going to want to keep track of what we've already seen, so that if a user uses it today and then they come back and use it tomorrow, we don't give them the same information all over again. So that's where persistence comes in, right? That's where we're going to want to write files and read files when we start up and see what have we already told this user, and make sure we don't repeat ourselves. We want it as automated as possible, right? That's one of the big things. One of the big advantages of Python is we don't want to have to go visiting websites and clicking on buttons and saving files. We want the code to just do all that for us. So we'll see how we do that today. I also really want this to have a nice user interface. So for our testing, initially, we'll use a notebook and we'll do some things with the Mu editor. But eventually, we want to actually make this something that people can use via the web. So they don't have to install anything. They can just visit a URL and start using this service. So that's what we're going to work towards. There are a few things I categorize as should. So these are not hard and fast requirements, but I think they're things we should strive for. We should be able to automatically run this app on a scheduled basis, meaning if you are a frequent user or if you sign up for this as a kind of a service, we should be able to run queries on your behalf to find out, what new articles are available that match your interests, and maybe send you a summary, an email summary once a week or once a day or whatever frequency you like. I'd like to have a more sophisticated way of determining whether an article is of interest to you, and we can use machine learning for that, possibly, let's hope. And this whole application will initially run on your laptop or in a notebook, but ultimately should run in the cloud. And we'll explore later what that means, run in the cloud, and how we can do it most easily nowadays. So we're going to use this, I think, as a stepping stone each week. So the first week today, we're going to focus on the initial part of the problem, which is gathering the data. and a little bit of formatting it into a format that we can use. Later on, actually next week, we're going to build a reporting layer. So we're going to learn about building a web server and how we would present this information over the web. And in the 8th lesson, we're going to do some modeling. So we'll apply some machine learning and some data science to figure out how to build a better analysis engine for figuring out whether the end user would actually care about this information or not. So the decomposition I kind of just went through. It's sort of these 4 phases, and these are really common steps in almost any data analysis project. You gather the data, you format it, which is often called data engineering. That's kind of taking the data as it was acquired and massaging it into a form that you can use it effectively in your program. Then we have modeling, which is a way we try to figure out, either what can we understand about this data by analyzing it, or what can we predict about new data that we haven't seen before based on the data we have gathered. And finally, we want to present some findings about the data. So that might just be statistics or analytical analysis, but oftentimes it's visualization. So it's graphs and other nice visual presentations that help us understand what's going on in the data we've gathered. So those are sort of the 4 general steps. And today we're going to focus on gather. And as I said, we'll probably do some formatting as well. Now, the first question I often ask myself when I'm starting a new project is, can we reuse some code? Has somebody already solved this problem? Do I really need to reinvent the wheel? And it turns out there is a really nice API called the Newscatcher API. It's relatively new. And it's a Python library that, in their own words, programmatically collects normalized news from almost any website. So there's a link here you can click on to read about it. This is a GitHub repo. For those of you who haven't heard about GitHub, it's kind of like Facebook for programmers. That's kind of a weird way to put it, but it's a coders network. People have accounts here, and they put their code up, and they share code with other people, right? So I can show you my kind of shortcut here from my repos or my site. And so it gives you like a little heat map of how busy a coder you are. And then there's all these repositories, and you can look at all the things I've been doing. And if you see something you're interested in, this is my personal blog. So I keep this on GitHub. You see someone else is doing some interesting work, you can click this fork button. And what that will do is give you a copy of that repo that you can then go ahead and change. If you see someone's code and you want to contribute to it, you can create something called a pull request, which is where you make some changes and then kind of pass your changes back to the original author or whoever is maintaining that project. So yeah, I guess I didn't mean to necessarily go into too much about this, but it's a good resource to know about. Almost all professional programmers are aware of this site at least, and many people do active coding on this site. And it's become the de facto way of almost like a resume or a CV for software people. What else was I going to say about that? Oh yeah, this all started with Newscatcher. So I found this library, and what's cool is if I want to, I can read about it, obviously, and I can use it. It's got the instructions here on how to install it. And if I want to, I can fork it and make some changes and experiment with it myself. And it is written in Python. So it's a library. Obviously, it's written in Python because I'm going to use it in our Python programming. But you can go ahead and explore this code and try to figure out how it works and all that stuff. But let's actually go ahead and use it. So the first thing we have to do is install it. And the program we use to install Python modules is called pip. So in a notebook, there's a special syntax with this exclamation point. Anything following the exclamation point in a code cell says, run this command as if I had entered it in a command prompt or in a shell window. So what that means is if I was on my local computer and I was in a command window like this, I could say pip install newscatcher, and it would install that. It would go and fetch that Python library and install it for me. In a notebook, because you don't have access to a command line, you have to do this exclamation point syntax. But all this does is it sends that command to the backend that we saw earlier and says, instead of writing this as Python code, run it as a command, a system command. So let's run that. And you get pretty much the same output you would expect to get from the command line, and the same output that I got, close to the same output that I got there. It's slightly different because this is running on a Linux machine and I'm on a Mac over here locally. But anyway, that is installed. So now we're going to try it out. First thing we want to do is import it. We're using this, instead of just saying import newscatcher, I'm using the from newscatcher import newscatcher syntax. And that means just pull this one symbol in from this module. Don't pollute the whole global namespace with all this, with this entire module's symbols. So I'm pulling this newscatcher, and that's an object, just like a file or a string. It's a special type in Python. It's a user-defined type. And what I do is I create this newscatcher object, and I tell it which website I want it to point to. So for now, I'm saying website theguardian.com, just picking that randomly. And it returns this object, which I can then use to start getting some news from that site. I'm setting the returned value in a variable that I name called NC, short for newscatcher. And then I say results equals nc.getNews. Now, where did this come from? And how do I know? Sorry, there's a barking dog outside my window. Hope it's not too annoying. How do I know to say get news? What is that even doing? How did I know to use this syntax? How did I know to say website equal? Where did all this come from? It's all came from the documentation. So I just went over here and I read it, and it tells me here's how to do a quick start. Right here you see the from import, and you see the nc equals newscatcher. I could call that nc anything I want. That's just a variable name. But this name here is actually a definition in the software. So I'm just following the instructions. Some of these packages are good and have really nice documentation. Some of them are not so good. If you ever do start trying to reuse somebody else's library, one thing you'll want to do is look up in the corner here at stars and forks. Stars should be like hundreds or thousands of people, and forks should be at least, you hope 100 or more, and watches should be decent as well. And that just tells you how much activity this repo's had. Another thing I like to do is look at the pull requests and see how recently people have been submitting things. Not that much activity on this one, actually. And look at some of the issues, how many problems people are having with it. Anyway, that's where I got all the information about how to use this. Let's just run it. And it didn't do anything. Well, it did something, but I can't tell because I didn't display anything. This thing that came back from the get news function or method, I stored in a variable called results. Let's just print the type. So earlier we saw this function called type, and I think there were some questions about when would I use this? Why would I use this? This is a great example of a time when you would use it. I don't know what results is. I don't know what it's giving me back. So I'm going to just print the type of it, and it's a dictionary. Okay, that tells me something about what it is. But I'd like to know more. I want to know what are the keys in that dictionary. So I'll just print results.keys, which is a method you can call on a dictionary. It's part of the dictionary type. And it just displays the keys in a list, I think. Yeah, so it tells you the dictionary keys are URL, topic, language, country, and articles. So this is 5. You can think of this as looking something like this. If you remember what dictionaries look like, they have this sort of syntax where there's a key and a value, guardian.com. Then there's a topic, and this will typically be the main topic, which is probably something like news, and so on. And in fact, instead of trying to figure out how I would manually rebuild it, let's just print out the dictionary and see what it looks like. Hopefully it'll look something like the one I imagined. So here's URL is the Guardian, topic is tech, which is, this is sort of like the overall topic of the whole newspaper, which I find surprising because I think it's more general news than that. But anyway, the language is English, country is Australia. I'm not sure I understand that. I was expecting to get UK. But anyway, you'll have to figure out why that is. But here's articles. Now, it's interesting. Articles is a key that points to a what? What is this? Well, the first thing we see is a square bracket. So that tells us it's a list. And it makes sense. Articles would be a list of articles. Okay, what's in that list? Well, the first thing we see is an open curly brace. That tells us we're looking at a dictionary. So articles is a list of dictionaries. What's in that dictionary? Well, there's a title. So this is an article title. Details, base, that's where the article is located on the web. It just goes on and on. There's a lot of sort of meta, we call this metadata. It's information about the article. Here's a summary. EU court in July ruled there were insufficient safeguards against snooping in US intelligence agencies. So this is an example of where, you remember when we were talking about nested data structures? Here is a dictionary within a list within a dictionary, right? The whole overall thing is a dictionary. It's a in this case, the dictionary of lists of dictionaries. So you see how these things can kind of get nested like these dolls, one inside of another. But anyway, that's what the results looks like. Now let's do something useful with the results. So one thing I was curious about is to find out how many, how big is this package? Is it just giving me access to a small handful of sites or a bunch? So I'm going to do from newscatcher import URLs, and this is a way to discover something about this package. And I'm going to say sites equals URLs. That just gives me, that's a function that gives me the whole set of URLs that are supported. And then I'm going to print number of sites. That's a list, by the way. It's going to be the length of that sites list. So 4,500 sites, that's pretty good. But I'd like to see what that sites thing looks like. So let's actually print, rather than just printing the whole list, because we'll get that spaced out horizontally, let's just make a quick loop for I in sites. It's going to be a list of strings where each string will be different sites. Each string will be a site that it supports. Print I. So I will take on the value of each string in that list, and each time through the loop, I'm going to print it. So let's see what that looks like. I'm going to get 4,000 of these, first of all. And that doesn't look like 4,000, but yes, it is. If I had scrolled to the end automatically, but now I have to go all the way up. I probably should have put a limit on this, right? Because this is kind of a pain to have to do all this scrolling. So let me get back. Let me grab the scroll bar. Okay. How would I just look at 10 of these or 20 of these or something like that? Well, a loop counter would work nicely here. I could say not because that's my loop variable. I could say count equals 0. And then I could say if count is greater than 10, which means jump out of this loop, terminate the loop. And the one thing I need to do is increment this this count, otherwise I'm never going to finish this loop. So let's say count plus equals 1. And now I just get 10, which is nice. But one thing I noticed when I had the really long list was that there were duplicates. I saw some sites multiple times, and I'm not sure why, but I want to weed those out. So what I'm going to do is go through the sites list, and I'm going to put each site in as a dictionary key. So this is what I mean. I'll do this. Yeah, let's do it this way. Actually, I'm going to, just to keep this simple, I am going to introduce a new type that I haven't shown you before. But there's a thing in Python called a set. And it's not too different from a list. But I want to show you what it's all about. So, you know how when we're making a list, we say square bracket 1, 2, 3, and then we can print the list. Well, a set is notated by an open brace, but unlike with a dictionary where you have key value pairs, you just have values, a sequence of values, just like with a list. So I can print the set just the same way as printing the list, and I get the same thing except for these curly braces. Now, I didn't tell you what's special about a set. What's special about a set is there's no duplicates allowed. So whereas with a list, I can say 2, 1, I can repeat elements, and I'll get exactly what I put in, 1, 2, 3, 2, 1. If I do the same thing with a set, Python is going to say, sets don't make sense to have duplicates. It just magically goes back to 1, 2, 3, or stays 1, 2, 3 is maybe a better way to think about it. Now, why did I just jump into sets out of nowhere? Well, the reason is because sets turn out to have this useful property that they avoid duplication. And that's exactly my problem right now, is there's a lot of duplicates. Just to prove that fact, I'm going to say, just give me anything. I'm setting s to be times, going through all the sites, and I'm saying if s in I, now I'm using the in operator on a string, which is basically saying if the string times is in the site name, then print it. So I'm basically going through all the sites, and I'm saying print any site that has the word times in it. And here's all the times, and now you can really see the duplicates, right? Wow, there's a lot of different times. There's the New York Times. There's like 8 or 10 of them. So now I want to get rid of the duplicates. So what I'm going to do is use a set, and you're going to see how super easy this is. All I have to do is say, I'm going to call it unique sites equals set sites. So what this syntax is doing is saying, take the sites list and convert it to a set. And that's just going to magically get rid of all the duplicates. I could have done that right down here with this little example. Instead of manually creating this set, I could have said s2 equals set of this list s, and then print s2. And I would have gotten the same result. So let me get rid of this, and let's run this code now. So this is just, and actually I don't need this loop anymore. Well, I guess I can do it. I'll do the loop, but instead of iterating sites, I'm going to iterate unique sites. And now we should just have one occurrence of all these duplicates. Let's try that. And we get an error. Probably someone out there is going to spot it before me. In string requires string as left operand. Okay, we don't have an S anymore. So I think I had set that to s equals times. If that helps. Yeah, okay, so here's all the times, but notice there's no more duplicates. Here's the New York Times. There's only one of them. But to really prove this out, let's count how many sites we have after we create unique sites. So let's get rid of that, and let's say print len of sites. That'll be the 4505 number. Well, actually, we're already printing that right here. Let's take unique sites. We don't need this count anymore. Let's say print unique sites, len of unique sites. And now we should see a different number between those two. And sure enough, by getting rid of the duplicates, we went from 4,500 to 3,400. Still a nice, healthy number of sites that are available to us, and good to know. But I just wanted to show you that trick and just also make you aware of this type called the set. I won't be telling you about every possible type in Python because there's so many, but this is a nice one to know about. You can iterate sets as well, just like, for I in set or whatever. Okay, so that tells us how many websites are supported. That's good to know. And they seem like prominent ones that we might want to query. How do we actually get our hands on the articles? So again, looking at the usage documentation, we're going to repeat this NC equals newscatcher on a particular website. We'll say get news. Then we're going to peel out of this dictionary that comes back the value associated with the key articles. And if you remember that this results was a dictionary, the key for articles was a list. So this articles right here is going to be a list. Can we prove that to ourselves? Let's just say print type of articles and comment this out for now. And sure enough, it says class list. Okay, so that's telling us this is a list. It's actually a list of dictionaries. We're going to print the number of articles. That's just the length of the list. And then let's take a look at the keys for the first dictionary, articles of 0. Let's see what's in an article. Okay, so not 48 articles that we found from The Guardian. And the dictionary keys for an article, for any one article in that list, the keys are title, title detail, links, summary, all the things you might expect to be associated with a news story. There's a lot of these. So now let's keep going and pull this information out for each article. So what we're going to do is say for I in article. So this articles is a list. It's a list of dictionaries. It doesn't matter. It's a list. So we're going to iterate the list with for I in articles. For each I, for each article, we're going to pull out the ID. I just happen to know that that's a unique identifier for each article. It actually turns out to be the URL, but I just want to be able to record that. And we're going to pull out the title. You see the title is right here. It's actually the first key shown. And then we're going to print out a count. So I'm going to start this count variable at 1. I'm going to print a count just to have like numbers along the left-hand side. Then the title, and then the ID. And as I said, these IDs are links. So we should see a nice lined up table because I'm using this F string that shows the count or the number of the article, the title, and the link to it. And then we, of course, have to increment the loop counter if we want the loop to ever finish. Actually, that's not true. It's going to finish by iterating through all the articles. We want to increment the loop counter here. It's not really a loop counter. It's just a counter. We want to increment it so we get a new count each time. So let's run that. And we get the number, the title, and the link. And if we actually click on one of these, looking for one that's not going to be too depressing, but they're all they're all horrible. Oh boy. Tony Hawk's Pro Skater, that looks pretty innocent. So if we click over here, we can see it actually takes us to that story. So we've captured the title and the link. And by the way, the point I was making about this not being a loop counter is that it's not determining how often we run the loop. It's just incrementing that number so that these nice little numbers on the left keep going up. If I comment it out, the loop will only iterate over the articles in the list. So there's no, I'm not creating an infinite loop. The only downside is these numbers never increment. So everything looks like story number 1. So I'll put that back in and we get these nicely increasing numbers. So now we're starting to really mine the information we want to get out of this. But there's also these topics, and I want to be able to say, I want to filter out the topics I'm interested in. But the first question is, what is the range of topics? Like which topics can I ask about? And this library has a function you can call to describe what the topics are for a given website. So I'm calling that function for 2 sites, Washington Post and 538.com. And then I print the topics. Name, describe, URL is not defined. And I think that's because I need to import that, and I forgot to. So I'm going to say from newscatcher Make sure I'm doing the case properly there. It's lowercase, so I think I should be able to just say from newscatcher import subscribe URL. Okay, so the Washington Post has these 5 topics, not a lot, but oral tech, politics, business, and news. And 538, which is mostly a political site, but also does a lot of sports, science, and economics. So now I know which topics are available, and I can actually request topics with or request articles with a specific topic. And the way I do that is I call newscatcher, give it a website, and I can also give it a topic like science. And then the rest of this code is pretty much the same. I have articles, I create this same table by iterating through the articles. And I get a list of all of the articles currently available on 538.com that are related to science. How to know when you can trust a COVID vaccine. I click on this link, it takes me to that exact story. So pretty cool. Now, this is all good, but I'm just running code now, and I really want to make this sort of parameterized or modularized so that I can use this functionality and build on it and not have to copy things from one cell to another. I also want to be able to iterate on it, right? I want to be able to do this over a multitude of sites. So anytime you find this condition where you're like, I want to do this a lot of times and I don't want to copy code that says to you, I need a function. I need to create a function. So I'm going to define 2 functions. And these should look relatively familiar because I'm just taking snippets of code like this one, and I'm putting it inside a function. In fact, let's look at how this function differs from that little piece of code. Here's the NC. So I've defined a function, get new articles. It should really just say get articles because I don't yet have a sense of what's come before, but I'll leave it for now. Get new articles takes 2 arguments, a site and a topic. And it says, creates a newscatcher for that site and that topic. So that's the equivalent of this statement down here, with the exception being that this statement hard-coded the site and the topic. That statement is only ever going to look at one site and one topic, whereas this function is going to take those as arguments. So now I suddenly have a way to customize the behavior according to my needs at any given point in time. The rest of this looks pretty similar. Results equals get nc.getNews, exactly the same. Instead of storing the results, I'm returning them because we're now in a function and we don't want to necessarily do anything with the results in the function. We want to pass it back to the caller. Remember, functions just do a limited task and they return the response to you so that you can do what you want to do with it as the consumer of that information. So I've just turned some code into a function. And the same thing with this display loop here. I'm not even going to copy it, but it's going to take a list of articles, and it's doing that exact same loop with the exact same formatting. So it's just an easy way to display a nice report. And with those 2 functions defined, look how simple my code gets. I can say in 2 lines, I can say get new articles, pass it a site and a topic, and I just say display results. And it sounds like it's doing what it's doing. It's very expressive. Get new articles is not defined. Anybody want to guess why that happened? Anybody still listening? That happened because I neglected to run this cell. So the define for these 2 functions, I forgot to run. Now that I've run it, get new articles should indeed be defined. And I can run this, and there I go. I get the exact same results. And you can try a different site. Let's try NewYorkTimes.com. There's all the articles about science in the New York Times, quite a few. I can change the topic to sports. And it says there. So obviously I need to do a little better with my error checking, because if there's no topic called sports, I I'm getting an error because I'm dereferencing something that's empty. It's this results of articles is assuming there's a key called articles. I can tell you how I would check for that right now. I would say if articles in results, then do that. I do need to return something, so I'll say if not, return none. Define it that way. And I'm still getting if articles in results. I guess results isn't a dictionary. It's just empty. If the library doesn't meet these criteria, I just get back something empty. So what I really want to say is if results equals none. And if you remember that rule, the Boolean rule that nothingness is false, I can just say if results. That's a way of saying if there's something there, then return the articles, and if not, just return none. Let's see if this time it works. Still doesn't work, but I'm getting a different problem. I'm now getting the error in the display function. So I'm not going to keep pulling on this thread, but you get the idea. You will encounter cases where your code blows up because it's assuming something exists that's not there. And so you want to try to make your code bulletproof by checking with errors. For example, this is checking that results is non-null. That's fine, but it should also check if articles is in results. So you want to always do these kind of safety checks. Okay, not going to worry too much more about that. We could keep going down that thread, but for now, I'm just going to fix it. I'm going to see if sport works. No. What would the New York Times? I'm surprised that New York Times wouldn't have. Okay, politics work. I'm surprised they wouldn't have sports. If we go back to that thing where we looked at the topics, let's just see what New York Times topics are. Interesting. There is no sports there. So I guess they just prioritize the main, what they consider to be the publication's main topics. And sure enough, they don't have sports. They do have food, which is a little funny to me because I would think sports would probably be more popular than food. But let's see what they have in food. Yeah, those look all foodish articles. Anyway, there you go. Now we have everything nicely packaged up into reusable functions, and we can query any supported site for any supported topic with 2 lines of code. So that's what functions and reusability is really all about. Now let's define some selection criteria and let's iterate, right? So far everything we've done has just been like one site and one topic, but really we're going to want to be able to do a bunch of things. So how do we configure this? Well, we want a list of sites and a list of topics. Actually, we'll make this a tuple because we're going to sort of set it hard-code it here and we're not going to change it. Later on, we'll definitely want to change it to let the user. Actually, let's just make it a list now because we're eventually going to want to make this mutable. And it's easy to do that. So we've got 2 lists. One is sites and one is topics. These are 3 of periodicals I look at frequently. Feel free to modify these, add any you want. And the topics, likewise, I just picked 3 random ones. And I just am printing these 2 lists to see that they make sense. That's a syntax error that the helpful editor introduced. So there's my sites and there's my interests. I should call it topics. Topics. There's my sites and interests. And now I'm going to write some code to use the functions we've been looking at. I'm going to set all articles equals to an empty list. And then I'm going to iterate over the sites. So here comes a nested loop. For I in sites, I is going to take on New York Times the first time through, Washington Post the second time, The Guardian the third time. first thing I'm doing is saying, what's the topic list for this periodical? So describe URL sub I says, call that describe URL function for this site. And whatever comes back, subscript the topics. Now that might be a little too clever. Another way to do that would be to say, I don't know what to call this. I'm just going to call it temp. Just going to get back a dictionary, and then I'm going to say topic list equals temp of topic. All I was doing here was sort of chaining the dereference into the dictionary right in the same statement, but probably a little bit overkill. Also, I have more opportunity to check for errors with this more explicit version. So anyway, I do describe URL, gives me the dictionary of topics, or yeah, the dictionary of topics. Well, it's the dictionary of information about that URL. And I access the topics key in that dictionary, which gives me the list of topics. Why am I doing that? I want to check and make sure that any topic I go to query is actually supported by that news site. So I'm doing I. Let's just kind of work through the first one. I would first be NewYorkTimes.com. So I'm getting the topic list for the NewYorkTimes.com. And now I'm iterating over the topics. This is the user's topics, not the New York Times topics. It's what I specified as my topics of interest: politics, tech, and business. So I'm going to say for J in that set of topics. And now you see a nested loop. I in sites, J in topics. So for every site, I'm going to do these 3 topics that I've specified. I'm going to print the names of the site and the topic with end equals null. So it'll stop there. It won't give me a new line. But I'm just printing sort of like the header for what's about to come out. And then I say, if J is not in topic list, print topic not available. So maybe maybe I had sports in here and the New York Times doesn't have sports. I don't want to have an error. So I'm saying if this site doesn't have this topic that I'm currently working on, show topic not available, and then continue, keep going. Don't try to get articles for a topic that doesn't exist. If I don't go into this if statement, then the topic's supported by this site. And I then call get new articles. That is my function. That's the one I defined up here. Right there, get new articles. It takes a site and a topic, and it goes and gets me all the goodies. Now, what's cool is the site is in I, that's my loop, and the topic is in J. So I just say get new articles, I, comma, J. Print the length, just as a check. That will come out after this little header. It'll show me how many articles of that site and topic matched. And then I'll add this set of articles to my accumulation of all articles, this empty list. And then finally display all articles is going to give me that nice table. I'm going to suppress that first and just run this and see what it shows me, because I don't want to have that big table. I want to watch it do its thing. So I did New York Times, topic politics, found 29 articles, tech, business. Then I went to Washington Post. Politics, tech, business. Then The Guardian, politics, tech, business. So you see that nested loop behavior. And you see it also captured this idea that the topic is not available. Because I'm checking to make sure the topic is or is not on that list, I should be able to put a bad topic and it should work. I say that a little bit hesitantly because I haven't tried this, but let's try sports. You can put a comma at the end of a list, by the way, and Python will be okay with that. And it avoids you forgetting to put the comma if you add a new entry. Okay, let's run that. Make sure sports shows up. There it is. And now let's run this. And it worked. So now it's doing politics, tech, business, sports in that inner loop, in the J loop. And each time it hits sports, it says topic not available, topic not available, topic not available. It'd be nice if I had one that actually had sports. Let me try si.com, Sports Illustrated. I'm hoping they have sports as a topic. Let's do that. Not available. I don't get that at all. Maybe it's sport. I don't know. I'm not gonna, another thing I'm not gonna debug. I'm good at not debugging things when I don't know what the answer is, but let's see. Sports Illustrated does have sport. So 50 articles. So at least it's good to see that adding a topic didn't break for where it doesn't have it and worked for where it does have it. Okay. Now this function, this iteration through the sites, just checking my time here, I have 20 minutes. Iterating through the sites and iterating through the topics, that's all great again, but I want to reuse that code. I don't want to have to copy it. I want other people to be able to reuse it, just like the way I'm reusing somebody else's newscatcher library. So all I'm going to do is functionize that code in that cell. So I'm basically copy pasting this cell and putting it in a function. I call it get news. And now instead of passing a site and a topic, I pass sites and topics. You get the idea that I'm giving it a collection of things to iterate over. What are these? These are lists. So it can say for I in sites and for I in topics, and I can parameterize the sites and topics now. This was limited to some values I passed it, it's global variables basically. Now I've got something that's fully parameterized. I can call this function with any list I want. And it's just doing the same thing, creating the empty articles, all articles list, iterating the sites, making sure it has the list of topics for that site, iterating the topics. Everything we've seen before is happening here. But instead of printing or displaying the report, it returns all articles for me to do whatever I want with. And here again, now I'm calling my function. Again, I'm reduced to 2 lines of code, but now I'm doing it for multiple sites and multiple topics. It's getting increasingly powerful. Let's run that. And get news is not defined because I did the exact same thing again. I explained this function to you and I forgot to run it, so it never got defined. It's now defined and I can rerun. It takes a little longer because it's hitting all these sites, but look at this. I got hundreds of results. And what would be interesting, here's all the Sports Illustrated stuff. Harper was apparently hitless. I'm not sure who Harper is, but good for him, or bad for him. 309 articles. So that's pretty cool. I mean, I want to encourage you to try this yourself. And because this is parameterized, instead of passing sites, I could pass another variable, or I could pass a hard-coded list. I don't know. What's a good one? I'll get that right. Seattle Times. WashingtonPost.com has to be a string, so we put the quotes. Washington. We'll keep the, actually we'll change the topics too. We'll just ask about politics. And now we're getting errors. None-type object is not subscriptable. So Washington Post, SeattleTimes.com. Let's go back to topics, but I have a feeling that's not the problem. I have a feeling one or the other of those newspapers is not supported, but I'm not going to try to debug this while you watch me flail about, but you get the idea that you can put any and ask the provider what he has against the New York Times, or rather the Seattle Times, but you get the idea. You can put any list of topics and any list of sites and customize this behavior. So we've really got the basics of a simple app. And what we're going to do in next week is we're going to add persistence so that it keeps track of which articles we've already seen for a given user by writing to disk files. And we're going to put a web front end on top of it so you can visit it in your browser and get these kind of results without having to run it in a notebook or a command line or anything like that. Lesson 6 homework is to do the questions below, which are going to quiz you on some challenges around reading and writing files. And question 5 is to take the Newsfinder program that we wrote above and run it in Mu so that you're running it locally outside the notebook. One thing I found when I did this was that I needed to install Newscatcher and something it depends on called feed parser in Mu. And I actually didn't realize there's a special way to install packages in Mu. You go to the bottom right, as I'm showing here, and click on that gear. And then it'll open up this dialog that says third-party packages. You click on that tab and you enter, just like I'm showing here, feed parser double equals 6.0.0 and Newscatcher. I know that's cryptic, but if you don't do it exactly like that, you may get some surprises. But anyway, if you do that and click OK, then Mu will have all the goodies it needs to run this code, and then you should be able to run it inside the Mu environment. So see if you can do that. And if you want to read more about, I mean, I gave you like a very quick overview of reading and writing files. If you really want to dive deeper, chapter 9 in the textbook, the online version of the textbook, has lots more detail about that. So you can feel free to learn more, go deeper there. Yeah, I think that's pretty much it. Next week, as I said, web servers and persistence, and I'll stick around. We're actually about 15 minutes early. What I think actually one thing I might do, just for a few minutes more. There's something called Coding Bat, which I showed you earlier, but I just want to show you how that works because it's actually really fun, and I think it's a great way to exercise your skills. So for example, there's these categories, and the one that I'm going to show you is from medium Python list problems with one loop, but there's a bunch of different ones, string problems and all sorts of stuff. But just to give you a sense of how this works, something called big diff, given an array of length 1 or more integers, return the difference between the largest and smallest values in the array. So as soon as I see I want to do something that has to examine the entire array, I think loop. I have to iterate over this array. So I'm going to say for I in nums. That's going to let I take on the value of every number in there. And what I want to do is find the minimum and the maximum. Now the minimum is going to be whatever is less than the minimum so far. And what's the so far? Well, let's start the minimum at some value. Why not just use the first value? And let's set the max equal to the first value as well. Now, we can do that because we were told the length is 1 or more integers. So we can assume there's at least one element in this list. So if you think about it, the very first element is both the minimum and the max. It's the only one we've seen so far. And what we're going to do now is go for I in nums. If I is less than the min, it's less than the minimum we've seen so far, well, this is the new minimum then. So we'll say min equals I. If I is greater than the max, if this is bigger than the max we've seen so far, then this is the new max. And we'll say max equals I. And now we want to just print the difference. Sorry, we don't want to print, we want to return the difference. So we'll say return max minus min. Now this isn't exactly how I would solve this problem, but what I like to show you is that, what you want to do is just start with something that seems right and try it, and then try to improve upon it. So I'm going to click go, and it says num is not defined. So I made a syntax error, it's nums. Try it again, and it passed all the tests. So this is logically correct, but there are a couple things I don't like about it. One is I'm starting off by setting the min and max to the first value, which is fine, But then what this loop is doing is it's iterating over everything in that list, including the first element that I already dealt with. So what I want to do is do everything but the first element. And that's naturally going to be a slice. So I'm going to say 1 colon to the end, and I can just use the shorthand of colon with nothing after it. So 1 colon says, give me the rest of the list starting with element 1. Now there can be a problem here because there might not be an element 1, and probably I have a feeling some of these are gonna fail. Let's try it. No, it didn't. I guess that list is just empty if there's no second element, and so this for loop is completely, it never runs. So that's cool. Another thing you could do is instead of iterating, you could just, well, these if statements could be min equals the min function, and this is bad that I called this min. I'm going to call it my min, my max, my min, my max, my min. I'm going to say my min equals the min of my min and I, and my max is going to be, I'm just using a well-defined function in Python for taking the min and the max. My max equals max of my max and I. So this should work as well. And even easier is min and max can take a list. So I could have actually just said, well, let me not rewrite all that. I could have just said the min of nums in one statement and the max of nums. And if you pass it a list, Python's smart enough to say, oh, okay, this is a list. I'll iterate it for you and give you the min and the max. So now I've got it down to 3 lines. And in fact, I don't even need these assignments technically. I could just do this. I might be overdoing it because, you know, if you get too fancy, then it's harder to read the code. But it's cool that you can get this down to 1 line of code. So really, that was just to show you like the thought process that goes into these problems. And that was one of the more advanced problems. You don't necessarily have to start there. In fact, I would start with the warm-up problems. But it's just a really fun site. And I think it's really almost addictive. Once you start using it, you'll want to keep going. And I think it's really a great learning tool. So that's it for this week. I'll stay on for a few more, probably 5-10 more minutes in case anybody wants to ask me questions. Otherwise, thanks for coming again, and see you next Wednesday.
Thank you, Mark. Bye.
Bye. Thanks for coming.
Bye.
Thank you, Mark.
Thank you.
You're welcome.
Thank you, Mark.
You're welcome.
Thank you, Mark.
Welcome. Thanks for coming.